There's one at the front desk.
Center, the Exploration Center here. Yep. I'll try this outside of the podium. I especially want to thank you for your patience, waiting for our technical difficulties to transit into something more smoothly and more successful. What I want to do is jump right to our guest speaker for today, Natalie Batalha. She is today's Kepler mission scientist with, joins us here to share how the Kepler mission uses transit to search for planets. You saw on the video that one of the ways that that transit helped us was to identify the distance of our solar system. Natalie began her career in transit photometry, the technology that was used to detect exoplanets back in the late 1900s. She's going to walk us through what's happening today as Venus transits the sun. I want you to help me in welcoming Natalie Batalha. Just a little bit of feedback. Can that be helped? Maybe turn down the volume.
Step away from the speaker.
Okay. All right. Can you guys hear me okay?
No!
No? It's truly inspiring to see so many faces here to share this moment with us. I can't tell you how that makes me feel. To know that there are people out there who feel just as passionate as we do about the cosmos and everything that's going on is really inspiring and uplifting. So thank you so much for coming. And as was already said, we also have to thank you for your patience as we ironed out some of these technical difficulties. I apologize for that. We've converted the file to PDF format and it's lost some of its functionality, but we're just going to make a go of it and get you guys out there so you can see this eclipse or this transit. You've been sitting here watching some videos that are very full of information content. You guys have been taken through the history of this event and why astronomers find it important. I have a little bit of that in my talk as well, but I think I'll de-emphasize those points and maybe try to give you a little bit of flavor for what this means to me as an astronomer, okay? Because I think the reason that this is meaningful to me is the same reason why you're here. I think that we share that commonality. There's something innate about human beings that make us curious about our universe, and I think that's what brings us here together today, right? So the title of my little talk is Catching Shadows. Astronomers are very, very creative and opportunistic about utilizing these coincidences in nature to learn something special about our universe. And that's what the Venus transit means to us in part. And it also means something to us in the context of the Kepler mission, NASA's Kepler mission, which is run out of here at Ames. So I want to try and tie those two pieces together for you. Every single rock suspended in a sunbeam is casting its shadow out into space as we speak, always. Even our own planet Earth is continuously casting a shadow out into space, and we aren't even really aware of it until perhaps we see that shadow sweep across the face of the moon in a lunar eclipse. Or perhaps just recently, you guys saw the solar eclipse. How many of you saw the solar eclipse that happened just a couple weeks ago? Excellent. So perhaps you've already seen this image as well. This is the shadow of our Earth's moon projected on the surface of the Earth. In another type of transit event, what we call these eclipses. And these eclipse geometries happen simply when one rocky body passes in front of the star, our sun, and casts its shadow on another rocky body. So here's the Earth, here's our moon, and here's the moon's shadow being projected onto the surface of the Earth, just like you saw in that great picture taken from the International Space Station. The converse can happen as well, where the Earth casts a shadow out into space, and the moon, in its orbit around the Earth, happens to pass inside of that shadow, producing a lunar eclipse. Now, the ancient Greeks knew all about this geometry, and they utilized these astronomical coincidences to compute or estimate the relative sizes of things. In fact, with knowledge of the size of the Earth, which the ancient Greeks had, they were able to observe lunar eclipses to see the Earth's shadow sweeping across the face of the moon, and to notice that the Earth's shadow was almost 4 times as big in space as the size of the moon, which means that the Earth is about 4 times as big as the moon, right? So they could use this coincidence to learn something about the universe, right? Now, fast forward just a little bit, maybe 1,000 years or 1,500 years from the time of the ancient Greeks, and we've got Johannes Kepler. And our story begins here. We're going to talk about Venus, not the goddess Venus, but the planet who is her namesake. And here she is up in the western sky, that bright point of light, the brightest thing in the night sky, in that western night sky, besides the moon itself, is not a star, it's a planet. It's the planet Venus, the evening star in this situation. So Kepler was the first one in the early 1600s to show that the positions of the planets in the sky can be fully explained by orbits, elliptical orbits around the sun. Taking the Earth from the center of the solar system and replacing it with the sun, he was able to work out the planetary orbits. And here you've got a cartoon of Venus orbiting our own sun in this next diagram. So he worked out these orbits. He knew that Venus was interior to the Earth. He knew the time it takes for Venus to go around once compared to the time it takes the Earth to go around once. And you can see from this geometry that it's not going to be very often that Earth, Sun, and Venus are perfectly aligned to cause this transit event that you've been reading about and that you'll see today, right? But Kepler in the 1600s, based on his knowledge of planetary orbits, he was able to predict when these transit events would occur. And he had a table of them. So even in the 1600s, we knew that this would happen. Moreover, we knew, just as we used lunar eclipses to learn something about the universe, these astronomers in the time of Kepler knew that they could observe this event and learn something else about our solar system. And that something else was the distance between the Earth and the sun. Because the relative distances in our own solar system up until that time were all relative to the distance between the Earth and the sun, which we just called 1. And invented a new unit, the astronomical unit. Say that 10 times fast. So by doing these observations, by knowing a little bit of geometry, you could actually have some hope of pinning down the distance between the sun and the Earth, and thereby setting the entire distance scale of the solar system through this one rare coincidence of nature, right? All right. So here we are today. We know that these eclipses, these transits of Venus happen about every 200 or so years. We know that they happen in pairs, separated by 8 years. So we had eclipses or transits of Venus in the 1600s. I'll talk about that in a second. Again, in the 17 and 1800s. Now fast forward to today, we've got another one happening. It's the second of one of these 8-year pairs. So you sitting here, even you children, who's the youngest child in the audience? Maybe this little one over here. Even this little one right here probably won't be around to see the one that happens next in 2117. Only her grandchildren. So it's a very special event. I hope you guys are going to enjoy it. This is a picture that was taken by a solar spacecraft looking towards the sun. The sun would be here in the middle. It's being blocked out by a coronagraph, so that because otherwise it would overwhelm, its luminosity would overwhelm the detector, right? So we block it out so we can see the tiny planet reflecting the sun's light next to it. And so that's Venus, and here she is approaching the sun in her orbit around the sun. So she's coming here in front of the sun, and then she's going to become the morning star instead of the evening star. And then she's going to go on her orbit around the back of the sun. And so this sequence of photographs was taken over the last 24 hours or so, and you can see that Venus is very, very close. I don't know what time it is, but we've got literally minutes before she touches, just kisses the limb of the sun on this approaching side, and we'll see that here in a minute. So let's talk a little bit more about history. This is this gentleman here that's depicted in this painting. Actually, this is a mural, and it exists in the town hall in Manchester, because this fellow, William Crabtree, was from Manchester, and he was one of the very first people to observe the transit of Venus during the event of 1639. Again, they knew that if they could observe this and take the right data, they could get the distance between the Earth and the Sun. And Crabtree did this, and he came up with a distance that was actually about 50% the current distance, which is, does anybody know what the distance is between the Earth and the Sun? About 95 million miles, right? And he came up with a value that was something like 54, all right? And then we've got the famous voyage of Captain Cook, traveling literally thousands of miles across uncharted seas in order to observe, to capture this one event. And in fact, there were scientists that were stationed all over the world, well, not all over the world, in the parts where the transit event would be visible. Places like Canada, Baja California, Pittsburgh, I think, had a station. There were in Russia, I think there were 8 locations in Russia alone where they were trying to observe this transit. And so they took these measurements, and Captain Cook himself ended up observing the transit of Venus from an outpost in Tahiti. Just to note that Captain Cook was sailing on a ship called the Endeavour. Does that ring a bell with anybody? Endeavour was one of the space shuttles. Yeah. And it was aptly named after Captain Cook's ship of exploration. And we know that Captain Cook went on after this to discover Hawaii. Did you know that? So Captain Cook lands in Tahiti. Here's one of the early maps that was a result of Captain Cook's explorations. And he observed the transit of Venus from this little outcropping here on the north, which up to today is still called Point Venus, in honor of that measurement. And here's an artist's picture of a painting of Captain Cook's ships in that 1639 voyage. Now here are Captain Cook's drawings, and what Captain Cook was trying to do was to time the moment when the disk, that is Venus, was just touching the limb of the sun. Everybody was making a similar observation. And let me just do a little exercise with you guys, just a little experiment. I'm not sure if they explained this in the videos, but I'm going to take a few minutes to do this. The way that Captain Cook was going to get and his collaborators was going to get the distance between the Earth and the sun was by measuring parallax. How many of you know what parallax is? Just a few. Okay, it's really simple. Parallax is what gives us depth perception. So if everybody can close one eye and hold up your thumb at arm's length and line up your thumb with my nose. Now shift eyes. Did you see that? The position of my nose relative to your thumb changed, right? And that's because you have depth perception by way of observing the universe through 2 different portals, separated by a couple of inches on the front of your face. So Captain Cook and the collaborators, scattered all over the globe, separated, just like your 2 eyes are separated, were observing the exact point of contact, the exact time when that disk of Venus touched the limb of the sun. And because everybody was observing this event from 2 different vantage points, they were going to see it happen at slightly different times. A very subtle measurement, but this is how they worked out the distance. And Captain Cook and his collaborators got the distance to within, I think, 1% accuracy. They came up with an answer of 95 million miles. So they did pretty well, don't you think? And that was in the 1600s. Okay, I want to make a few comments. Not sure how I'm doing on time, and time is of the essence, so let's be mindful of time. Does anybody have a watch? 2:40? We got lots of time. Okay, so this was going to be an animation, and unfortunately I had to export my file to PDF, so it's not going to work. But no worries, I'm going to be able to explain it to you anyway. What I want to say to you today is that astronomers today, in the year 2012, are still making use of astronomical coincidences to learn something about the universe. The coincidences that NASA is using right now on a spacecraft orbiting the sun called Kepler is the alignment of other planets orbiting other stars in a way that they transit the disk of their star, thereby casting their shadow out into space with the hopes that that shadow will sweep across the face of our telescope and we will perceive it as a momentary dimming of light. Okay? So the Kepler spacecraft is not seeing planets transit in front of their stars in the way that you are going to see it today when you go out to the telescopes or you watch it on the screen. All Kepler is doing is measuring a total system brightness. And that's what this animation was going to show. When a planet transits in front of that disk, we measure the brightness as a function of time, and when it transits, we will see that brightness decrease and then increase again. And by taking these brightness measurements, we are able to infer the existence of other planets orbiting other stars. Nature's coincidences, right? So here's a little cartoon of the Kepler spacecraft out there orbiting the sun, staring at other stars in our galaxy. Again, it doesn't see stars like this. The stars themselves are but pinpoints of light. All we do is measure their brightnesses, as you saw in the previous cartoon. But the question, the real question that Kepler is trying to answer is this one that's written here. What fraction of stars in our own galaxy harbor potentially habitable Earth-sized planets? We don't know the answer to that question yet. We've all seen lots of science fiction movies, right? Pandora and all these planets, planet Vulcan that Spock lived on, and we think to ourselves, surely there are going to be planets like Earth that are out there. But no, but that thinking about it and actually knowing it are two different things. And what we want to do is to know it, to really know the answer to that question. So that's what Kepler is trying to do with this spacecraft. And what I'd like to do now is show you these two cartoons. This is a picture of two suns, or a star like our own sun, and there are two black disks superimposed on it. The one on the left is a black disk that would be about the size of a Jupiter. The one on the right is a black disk about the size of the Earth. And Venus is a twin of the Earth, so Venus is going to look very similar to that today, right? So you can see why this is very difficult to do, why we need a space-based telescope to do it. Because that dimming of light that Venus is going to produce is only 1 part per 10,000. Imagine you had 10,000 light bulbs and you just took away one. That's the change in brightness you're trying to measure. Imagine you looked at the very tallest hotel in downtown San Francisco, maybe 30 stories high, and every single room was occupied and it's nighttime. And every single light is on in that hotel. And one person in that hotel in one room lowers the blinds by about 2 centimeters. That's the change in brightness that we're trying to measure looking at these events to detect these planets. And then finally, what I'd like to do is get you to think a little bit about the future. You're seeing these cartoons here with this planet silhouetted against the disk of a star. Can you imagine that some of this starlight is filtering through the atmosphere around the planet? Can you imagine that? And as that starlight filters through the atmosphere around this tiny little dot, The atmosphere itself is going to leave its fingerprint on that light. So that if we catch that light and we spread it out into a rainbow and we look carefully enough, we have a hope in the future of being able to tell what's in that atmosphere. So here's a picture of the limb of our own planet Earth, and you can see that very thin blue haze which is blanketing our planet Earth, right? That's the blue haze that the sunlight is going to drift through. That atmosphere is going to leave its fingerprint on the light that comes through it. We catch the light, we spread it out into a rainbow, and do you know what we're going to look for? What? Oh, whoops. This. Does anybody know what that is? What is that? It's a bubble, yes. What's inside the bubble? This green stuff that you see is algae. It's algae. It's cyanobacteria. Some of the oldest fossils, or the oldest fossil ever discovered on planet Earth, is about 3.8 billion years old, and it's from cyanobacteria, this blue-green algae. This blue-green algae, as it eats and metabolizes and reproduces, it lets out a little gas. But that gas is comprised of, any guesses? Methane? No, that's cows. Air? What kind of air? Oxygen, yes. And this little bubble, this little cyanobacteria, that's what produced the first oxygen on planet Earth. Oxygen is not produced by geological processes in great quantity. It is produced by biology, by life. So nature's coincidences. If we can find Earth-sized planets just the right size at just the right temperature, if we can collect the light from the parent star that's filtering through that thin blue haze, we have some hope, maybe in your lifetime, of finding places where life might exist. So that's what the transit of Venus means to us today. It's nature's coincidences. It's going to give you, I hope, a profound feeling of the grandeur of our own solar system. You're going to see Venus in person with a spotlight shining on her. Moreover, you are going to see her winding her way through the solar system as she orbits our parent star, in the same way that our own Earth winds its way through the solar system. So I hope that that gives you a few things to reflect on as you see Venus. Again, I'm just delighted that you're out here watching it and sharing this moment with us. It does mean a lot to us. Find a scientist, talk to the guys that have telescopes, ask them tons of questions about Captain Cook, and enjoy yourself. And with that, I think I'll call Dorothy back up and she'll give you some instructions. Thank you again.
Have activities, hands-on activities.